Good afternoon. Continuing the BGP and Security Festival, let's talk about another aspect of those two, the BGP transport security. So what is the context of all of this? All of the things are well, fashionable and very widely visible right now, but this is about a different aspect. It's about a transport security, MD5, and some false perceptions in the community, especially the security community, of how routing people use these things and whether there's... If we look at the MD5 as a transformation or hashing function, it's not considered to be cryptographically strong. Therefore, when security-aware people see that in developments of the new routing protocols or in, say, applications of those, they typically get scared by it. So let's take a look at that problem. And if there is a problem, it would be very interesting to gather your feedback, how to address that. So if you care about this problem, please voice your concerns. The BGP security, it actually doesn't exist as such. BGP was created without any historical, and all the things were added as time went. Therefore, the transport relies on whatever security mechanisms the underlying session transport can provide. Now, it might be considered as being not too important because all of the, say, high-value attacks lie on a BGP. That's not correct. However, there's an assumption in the BGP information security protection mechanisms that the underlying transport is secure. So both the origin validation and path validation, they signal certain path attributes. If somebody can intercept a session and change those attributes on the fly, no transport authentication is used, it's questionable whether such BGP information security is practical. So how does BGP interact with transport? Very simple, it's TCP. And TCP is vulnerable to quite many of the attacks. One of the most visible ones being injected as reset into the current window, well, the session closes. And that was the one of the initial goals why the family of mechanisms called TCP authentication were developed. And indeed, they have been for long. They solved this problem. Just that in TCP authentication mechanism in wide use, what are called the MD5 signature option, has only one hard-coded algorithm, has only one key, has no ability to signal that I want to change the key, has no ability to signal a lifetime of the key, and, for example, changing the key of the session or initially out-of-band communication. There's another option implemented by a set of vendors to a varying degree and a varying level of interoperability, what is called enhanced MD5, which allows you to have multiple keys, indicate a key lifetime. However, that is not universally global interoperability. There also exists a nice all-solving option called the TCP Authentication Option. It has been around for around a decade. The only problem is that it has been around in theory. So yes, there is an RFC published. However, there are no practical implementations. It used to be one from the commercial vendor, but that vendor is no longer around. Therefore, in theory, we do have a solution. In practice, we cannot use that. There are some vendor proprietary mechanisms which try to address that. However, in this context, we cannot talk about interoperability at all. We have reacted to that and developed a whole set of both extensions and best practices of how to solve this without requiring a need for, say, strong and versatile transport authentication mechanism. Those are really best practices that you should be using anyway. So TTP can send a trace session into your network. You probably have far bigger problems than potentially cryptographically weak MD5 hashing function used. Graceful restart also is one of the right mechanisms for protecting against these types of attacks, and in general, applying to your network. And, well, on top of all of that, you can set up the password or secret on your transport sessions and use what your vendor allows. However, if we try to look on a wish list, if we were to design a new thing or just an existing one, what would be the requirements for BGP transport session security aspects? Probably we can group them into 4 large areas. So first, the session can stay up for a long time, and long time it's probably on the magnitude of years. I'm not completely talking about the aspect whether it's the right thing to keep your router unupgraded for several years just to maintain the session lifetime. However, well, there are mechanisms which allow you to keep the session up even if you do a switchover of the platform. There needs to be an ability to signal and to negotiate a different cryptographic transformation mechanism than just only MD5, maybe one of your particular choice. One of the big areas in operational pain with BGP session authentication is the initial synchronization of the key. BGP as such doesn't have any mechanism, and you need to use some out-of-band channel, phone, pigeons, letters, or other things to synchronize the password with the other party. And also what is operationally required is an ability to roll from one key to the other without disrupting the session itself, and do that in a more robust and deterministic scenario than we have to deal now with switching from one MD5 key to the other. And well, two small but important aspects. This needs to be practically usable, and second thing, this needs to be practically implementable by the vendors. The story with TCP-AO is that it's theoretically usable, but nobody cares to implement that. A brief look at the possible transport options in the context of evolution of BGP. One of the possibilities is to use TLS. All is fine from a, say, security point of view of that. However, TLS does not protect the TCP session header itself. And therefore, we still are vulnerable to the session resets. IPsec, yes, certainly can be possible. However, most of the practical implementations treat IPsec interface as another interface, as a tunnel. And running BGP over tunnel is certainly possible. However, you need to be careful. That simply increases the operational complexity. BGP over QUIC. QUIC is a new transport protocol being actively developed in IETF, which looks rather promising for this option. MACsec, if you want to look deeper, however, not everything in the world is Ethernet, and not all practical platforms allow for an easy application of that for the control plane termination of the traffic. Of course, being the network engineers, we certainly can invent a new transport protocol for BGP. That's a lot of fun. And then the sad option at the very end, we do have a seemingly practical solution, but however, we cannot use that. The TCP-AO does not exist. So, open questions to the community. First, a large one. Do you think this is a problem, and do you care whether this is a problem, and whether you have any sense that this can be solved, or you are happy with the things as they are now? And if we try to look deeper, those four large areas, the initial key synchronization, long lifetime sessions, the rotation of the keys, and ability to select different transformation algorithms. And also, what to do with TCP authentication option. Technically, this problem is solved on paper. Maybe the only thing that is required is to put pressure onto your favorite vendors to ask for implementation. And also, what about the alternative transports for BGP? So that's the end of the story from my side. Questions and comments, please.
Job Snyders, NTT. I noticed that in your proposed transports, all of them have in common that there is encryption, and I would consider that a bug rather than a feature. I'm all for authenticity or authentication, but encryption would significantly make debugging harder, and I would not consider that a requirement. There is no need for privacy, at least in internet routing.
So that list does not assume that you need to use encryption as such, just that it provides you authentication with the added, well, value or harm of encryption.
And secondly, we could maybe consider opportunistic upgrading, like we've done with Start TLS and BGP. Out of the alternatives that you have offered, starting from scratch seems almost attractive.
Well, for engineers, yes. What would you expect?
Okay, one more right quick.
Benedict Rudolph from DKIX. We run lots of BGP stuff as well. So for us, it's currently now working, but it's far from ideal. So TCP authentication option would be okay for us if it would be there, but it's not there yet. So if there's anyone wanting to implement it, it would be good. I think it's a fundamental principle in cryptography to make the mechanisms exchangeable. So whether it would be MD5 or SHA or whatever in the future, this should be considered in the design of a future protocol. And if if TCP-AO doesn't make it, then maybe we have to look for other transports. But I think we should try at least once more to make TCP authentication option a reality, because on the paper it looks good, as far as I looked into it.
Yes. So that's exactly the situation that we have in the industry. Technically, we do have a solution. However, we cannot use that. And operators cannot use that because none of the vendors implement that. Vendors don't implement that because they don't see enough of a pressure, and they are not charity houses. They will not just implement that for fun. So that's, to an extent, a closed loop.
Okay, thanks.
Thank you.
Yep. Okay, next up we have David. He's going to talk about legal barriers to securing the routing architecture. David? You have to use the podium mic. And only green buttons. This one too.
Great.
Yep.
Great.
Awesome.
Thank you. Hi, I'm David Wishnick. I'm a fellow at the University of Pennsylvania Law School. That means I'm a lawyer, not a routing engineer. So over the course of this presentation, I hope you'll gain some insight into why I'm here at NANOG. I also am going to make a request of you throughout the course of the presentation, but first I'd like to pose a problem, and it's a familiar problem from earlier presentations today. And that is that BGP updates in an unverified manner. It relies on transitive trust. This has been a theme over the past few presentations this afternoon. Unverified routes are vulnerable to mistakes and hijacks. As Andrei Robochevsky said, 10% of ASs were affected in 2017 by events like this. And I think you can kind of get a nice glimpse of a potted internet history by considering some of the most prominent events, routing incidents over the decades. So in the late 90s, AS 7007 and 8584 announced large pieces of the internet. In the late aughts, Yahoo and YouTube were either unreachable or diverted. And lately, we've seen some incidents involving financial services traffic, and even a heist of some cryptocurrency involving a routing incident. But in a community like this, where there is a problem, there are solutions. One of the solutions is RPKI. It's a partial solution. It focuses on origin validation, not path validation. And it's what's driving the research I would like to talk with you about. So RPKI is a global initiative to secure routing announcements. What it does is it gives encryption keys to IP address holders through the RIRs. And those keys can be used to sign what are known as route origin authorizations, ROAs. On the flip side, you can take what's been signed, and you can filter routes, either by depreffing or by dropping invalid routes on the validation side. So that's our partial solution. And here is a graph from the NIST RPKI monitor from about 2 months ago that shows where we're at. It's in log form, so maybe a little hard to read, but I think that there are two things I'd like you to take away from this graph. The first is that adoption of ROA deployment is relatively slow to grow, and even in the regions that are leading the pack, which are the RIPE and LACNIC regions, not huge deployment. They're in the teens and 20s. And then the second thing is that there is a gap between the leading regions, RIPE and LACNIC, and then the other three RIRs, which are much lower. So that is where I and the principal investigator of the NSF grant that I'm working on, Christopher Yu, he's a law professor and also a professor of engineering. He and I are doing research on the barriers to RPKI adoption. Our goals are really to understand those barriers, and there's also a sense that there are some legal barriers. That's where we come in. We are investigating those legal barriers, doing some research, independent analysis, and we're going to propose viable solutions to overcome those barriers, and we want those to respect all stakeholders. So I'm coming to you as stakeholders and asking you to help me do that job well. We've done 2 or 3 dozen interviews over the past few months with stakeholders in the community, and we've developed some hypotheses about what's holding back RPKI adoption. The first might be economic incentives. You can think of adoption as a chicken and egg problem. If you are trying to decide whether to start signing your routes, you might ask reasonably, how many people are validating? How many people are filtering based on these ROAs that I'm going to throw out there? If it's low, it might not rise up in your priority list during the workday. On the flip side, if you're thinking about whether to validate, it's a reasonable question, how many people are issuing ROAs? And so that's one story. Now, that helps explain maybe the slow pace of adoption, doesn't explain the gap between regions. And there's also a happy side to that story, which is that if it's a chicken and egg problem, that means there could be a virtuous cycle where if adoption grows, it becomes increasingly more valuable for other people to adopt. So you can hit a tipping point, and then it becomes an exciting thing to watch. Another possibility that we've heard is culture. Maybe in some regions, there's just more of an appetite for a collective solution like RPKI that requires investing in solving that chicken and egg problem. Or you might think that internet topology is doing a lot of work. We've heard that the IXPs are big drivers of RPKI deployment in some of the earlier presentations. There are more IXPs in Europe than there are in, say, North America, so that could be part of it. Then the last one, law, which is what I'm coming to ask you especially about. And there are basically 2 sets of legal barriers that we've identified. Some have to do with the contents or perceptions of the contracts and agreements that the RIRs use to govern the use of the cryptographic resources. And then legal background. So different laws apply in different communities and different jurisdictions. And so the key ones are rules about data sharing, and then also rules about allocation of liability if something might go wrong involving RPKI. So, we've done interviews and would like to do more with people across the community. We've talked with commercial firms, academic institutions, government entities, engineers, researchers. I would love to talk with you if you have any thoughts about this. And we're also, as I said, we're doing our own independent research and analysis from a legal perspective. So the bottom line is I'm seeking your input because I want our proposals to respect all the stakeholders in the community and do the best job of solving some of the legal problems that might be holding back RPKI deployment. So if you have experience with RPKI or services like it, come talk to me, find me, email me. If you'd like to share your views about your organization's approach to procurement services like this, come find me, talk to me. Or if you have views about the deployment path for RPKI, I would love to hear from you. So my email address is on the board, and I'd just like to thank you. I'll take questions.
Barry Green from Akamai. If you go back to the elements like B factors, a couple slides.
This one?
Yeah. So number 1, it's clue, right? Number 2 is workload. Then you get economic incentives. And you get down to the law and you ask people questions. One of the things that we've been batting around in the community is, and where your expertise can come in, and if you ask the questions, is what if you have a peering contract, not a peering agreement, but a peering contract. As you saw in there, the stability of the routing system has now as a business threat. It's not the internet anymore. It's not telecoms anymore. Everybody's cell phone network right here can be affected by BGP hijack from Iran, right? Because of state attack and something going on out there. Maybe it's time to put it into contracts, right? Which is a legal standpoint. And that would be one of the questions to go through and ask us is, what if you put it, not instead of a handshake and then, he and I can handshake and we got a peering agreement.
Yeah.
Right? That's how we peer on the internet. Right? That doesn't, but that's not business anymore. So if you can think down that route, that can help the community in your work with it, so it's not, you know, duplicating, but it's like, since you got legal expertise in there, that's an area that could really help the community. What if you put RPKI in a contract?
Yeah, well, I'd love to talk more with you about that idea.
We have time for one more.
Hi, Marty Hennigan from Twitch. I don't think there's any legal barriers. I think that that's a business term in a contract. And there are pairing contracts, especially between the bigger networks. They're actually quite common. And we as operators could place a requirement for RPKI in those agreements if we desire to. And I'm sure that as a business term, it would be no problem.
Mm-hmm. Well, that would definitely be a lever. Do we have time for a job?
Just, yeah, go ahead.
Job Snijders, OpenBSD. The legal aspect we're referring to is that I, as an operating system vendor, cannot ship some of the trust anchor locators embedded in my software distribution. So we're not talking specifically peering agreements, but the right to distribute and republish certain cryptographic resources without constraints. But thank you for doing this research. I am rooting for you.
Thank you, Jeff.
Thanks, David. Okay, thanks, David. Please do get with him in the hallways and give him some good feedback. Okay, next up we have Mehmet is going to talk to us about submarine cable status map. Anything that's green, this will advance.
Perfect.
Yep.
All right. It's not really my first talk at NANOG, but I'm excited like if it is one. So my name is Mehmet Aksin. You might remember me from ICANN, Microsoft, recently Yahoo. Great to be here. So let's get this going. It says the problem at the beginning, but I actually don't know even if it is a problem that I'm trying to solve here. I'm just obsessed with the ability to visualize the status of things that are working and that are not working. And I have this spare monitor in my home which is connected to a Raspberry Pi. And during my last couple of years when I was employed by large networks, I always displayed proudly the networks that I was building and their statuses. And now that you know, I'm doing my own thing, I kind of don't have that visibility. And I was thinking how I can put together the submarine cables and their statuses, where they're operational, they are you know, down, or the maintenance, fiber cuts and stuff like that, shark bites, that also happens. But I noticed, you know, it's 2018 and this doesn't exist, or exists maybe very, very limited basis to one cable, two cables, something like that. Hasn't it been done? Maybe it is just extremely hard to do it. Maybe it's just too much of a coordination. There are so many cables, around 300 of them, that are under the sea, that are operational today. There are more than maybe 1,000 people involved, 1,000 different companies operating it. So, you know, I wanted to start an experiment, and I would like to ask you guys, actually, please feel free to ask and make comments or reach out later on if you think this is just a waste of time. And I actually want to quickly ask, who thinks this is a waste of time? Okay, at least good. Okay, well, let's see. You know, there might be also some security concerns. I have reached out to Submarine Cable Project Protection Committee and asked them why they think such thing, if they think would be like a security risk and all that. So I'm working with them. I'm working with several government representatives from Washington, D.C., asking them, you know, how we can make this available just for general public. And I want to go on the record. We are recording this, right? This is streamed and all that. So I don't have any intention to make money out of it. The only thing I want is that for all of us to have a place that we can put in the NOC and enjoy the view, and then maybe just see something is going up and down. And you know, if there are people that wants to build upon it, and I want to be able to enable that, so maybe an API, etc. So just kind of wanted to go on record with that. And the marketing. So some of the cable companies, submarine cables that I have reached out and I talk, they were a little bit worried. You know, oh, you know, this is not the positive marketing. Well, unless it is CME-v3, I don't think anybody really needs to worry that, right? So why? So the problem statement is that we don't have a common place where all that submarine cables we can see which one is up, which one is down. So obviously, if you are currently, please raise your hand if you are buying submarine cable, leasing, whatever. Okay? Wow. or not buying, but like if your network has a submarine cable capacity, please raise your hand. Okay, good. Raise your hand if you don't have a backbone, but you have an international presence, intercontinental, which I'm assuming the rest. Okay. Or maybe interesting, your customers have. So if you're buying capacity, contractually, you're getting notifications when the cables are up and down or something is going on. But if you're just using transit, then you're suddenly seeing a 70 millisecond latency going 120 milliseconds, you don't really know what's going on. So one of the ideas that was given to me throughout the discussions in several months is that how can we have an API that talks to the NOC, and when NOC sees a 20 millisecond jump and at the same time a cable associated, it will avoid some false positives so we can sleep, right? I'm a network engineer, so I don't know, but I don't like to be called out for false positives. So moving forward, obviously this could be something cool that we can just display, but also something really useful when we are troubleshooting some issues. So how I want to do it? I am not exactly sure. So let me be very honest, okay? I have never started a startup, or I've never started a nonprofit organization. I'm like clueless, okay? I have talked to several people who are clueful, like Aaron Hughes. If Aaron is here, please thank you very much for him for giving me some ideas on that, and several others. So thanks everyone for that. So here is what I don't want, right? So I don't want to make money. I want this to be self-running, self-governing. I want experts and engineers as yourselves to help build this and be part of it. Very similar to peering DB, right? I think we can all say that we have together built the peering DB, and by contributing information and helping govern it. So we have challenges though, because we need to make sure the data is accurate, right? The data, the ownership of, like, we don't want some competitor to have gain access to the, this map and suddenly use it for marketing purposes negatively, go take down a cable showing that it's down and use it for marketing and stuff like that. So obviously the challenges we are talking about, I have used LinkedIn. If you are not connected with me, I have my LinkedIn address later on. I have used that for my main communication because not every Twitter, I guess, or GitHub. And basically, I have received more than 20 different requests, all the way from notifications, all the way from, how can we get email notification? Can I group various submarine systems that I have and then get based on notification? Let's say you have access to 2 across the Atlantic, or let's say 4, and you only want to be notified if 2 of them are down, not 1, things like that. And some of the reporters reach out to me from, some really, big news agencies, and they offer, hey, we would like to write articles about this, statuses, and, can we get like notifications on, historical availability and stuff like that. Of course, I don't want to get into that kind of stuff. Governance and sustainability of the service is very important. I don't want to be the middleman. I don't want to, be the manually updating guy. Data, so thank you very much for telegeography for providing this data publicly for the actual submarine cable data, making it publicly available for people to consume. Obviously, they've been doing fantastic work with the static page they have that shows all the cables as well as, the cable maps. That needs a little bit clean up. I didn't notice myself, but I have been pinged by maybe, many, tiny errors, but like it's showing like maybe different landing station, maybe the different RFS dates or different length of the cable and stuff like that. And of course, funding and prioritization. I just want to make sure that this can self-fund itself and it can run itself without me, constantly dealing with it too much. So questions for people. Is this interesting? So if you think it's interesting, could you please raise your hand so I get a little bit motivation? Awesome, thank you. That was good. Is it interesting to see the national backbones? I mean, can we create something that, and I'm not saying I will do that at all because that's a huge work and I don't think anybody can do it, but NDAs, blah, blah. So does it make sense that we have this create a platform where everybody can submit data? Is it interesting? Deciding governance model and proceed accordingly. If you guys think that it's spending time money, efforts, because it's going to be a little bit of all of your efforts as well. Is it worth pursuing? So I need help with the prioritization. What I want to do is I'm going to create some polls once we decide the governance model, and it will basically show on the features, actually openly let people vote. Okay, which feature gets the most vote gets to be done first, or which one has funding gets to be done first. APIs, GitHub, I said GitHub integration, but what I really meant to do is all these KMZs, and the way that we are working right now, actually we have several partners that are already providing data, and I will call them out later. We want to make sure that this KMZ files that they're providing us is available, because they are very open to sharing this data, and it's already available in many ways. So maybe GitHub integration and possibility of creating different maps. Maybe some other maps that we didn't think of. All right, so you can see here, I am not sure if you can see it very clearly. I have a link that I will share with you guys later, but this shows every cable that is operational and planned, okay? And then you will see some green going to Alaska, you will see some going to Brazil, and you will see some in Africa. Those are the companies that are currently giving, so this is like a cleaned up version, because this is the only cables that currently I have, active data. So the way that I'm doing this, I thought about, okay, I can probably get like people email me and I could manually update. Well, that doesn't scale, as Vijay Gill would have said. And what I'm doing right now is, this is a Google map. There's a Google sheet attached to it. And basically, I'm providing access to people, the NOCs or whoever really is involved with the cable. Sorry, I know I'm running out of time. So this is pretty much it. I'm sorry, I didn't really have a lot of time for the questions. But what I want to really do this, there's an emailing list that I created. Feel free to subscribe to the list. Feel free to make suggestions. And if you guys have any questions, you can also ask there. And let me know if there's anything I can answer right now. Thank you.
Thanks a bunch. Actually, the data geek in me loves seeing that kind of stuff. So